Yo, YouTube, YouTube. Uh, so be just doing a little coding video, I guess, a little offline code sesh with it. Um, cause I couldn't fall asleep because I wanted to do some coding, so that's what we're gonna be doing, right? Um, I'm just gonna be working on some of my libraries and stuff that I've been needing to work on. And yeah, I don't know how long I'm gonna be here, but we'll see how long this lasts. I do wanna. So let's talk about what I'm doing here. So I'm making a hooking library. Let's just call this the koi hook here. So that's what the library is called. I named after my cousin. Yeah, I guess. Um, Koi hook. Mm, 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 mm. Anyways, so let's see. Let me explain this. So I'm working on this library here called Koi Hook, right? It's gonna be a replacement for Minhook for the cheat I'm currently developing. So we go to my other library called Hooker. Uh, this is how I'm currently performing hooks. Just don't look at this stuff. Yeah, it's the whole thing. It's kind of embarrassing because yeah. So I had no idea what ordering was when I was working on this, and I still don't really know that much about it anyways. But um, yes, everything is ordering relaxed. So yeah, which, as you know, order and relax basically means that the compiler and CPU can do whatever the fuck it wants to with the ordering, so things can be out of order and do it, just go buck wild with it. So my current libraries uses Minhook internally. Minhook initialize, with an call enable, uninitialize. Uh, our disable function for the hooks is just calling Minhook disable, mapping the errors, printing them out, whatever. So the goal is to replacement hook. And here we have, um, so we have our trampoline hook function, which just takes a target function and a detour function, and uh, it'll just do this right here. So it will copy the bytes of the push register. So we're going to push all the registers before we actually call our detour function. And then we will call the detour function. Then we will pop all the registers after we return. Then we will write the overwritten bytes from the original function. So then we'll run those bytes. And then we will uh, write the jump to our target function. And then we'll jump to that. And then at the end, we will actually write the jump to our trampoline to the target. And then we will make the permissions at our area to be execute, and read. Um, because originally we made them page, read, or write instead of execute, right? So arguably, we should probably move this to there because it won't be executable when this is written. So maybe the function will get called before um, that's written. So we'll move that to there. But anyway, so I wanted to develop a function here. I was thinking about my bed, which we can pull up our tools, go to Ghidra here, and I'll kind of show you like what I'm thinking about doing here. So if we just go to like any of these inline hook ones, or just take a look at these. So this is the print name function here. Go back. Let's just go to the main. So where it's called at. What was that right there? Image runtime. Exactly. Image runtime underscore function entry. I wonder what these are, because minhook is able to hook the function, right? Like you call, like we go to our library, right? Of hooker. When you when you call minhook to enable the function, it will return back um a trampoline, right? So if you call it by create hook API, it returns back a target. And then let's see. Honestly, I wonder how this thing exactly works. I'm not sure because they have it like pretty. I want to make it better, like nice to Minhook, where I can have my own like I guess metadata attached to the trampoline function, which will auto do atomic counting and stuff for when I want to unload. Right, so I'm not unloading a anyways. So the image runtime functions, I wonder what these are. Is it way I can overwrite just this right here? Like overwrite this function pointer, so the begin address right here. I wonder if I could do that, if that would change anything, but I don't think it will though, because these functions are all just like the jumps to them just go directly towards them. I don't think this would matter, but image runtime function, true. Contains detail about the runtime exception processing, the structure, the corresponding by format, begin address, exception handler. So yeah, this is just the last function of the function is a function that address. So I don't think this has anything to do with calling the functions. Um, so image runtime functions. Anyway, so I think what I'm gonna do is so we go to the fuck man. So if we go to the print name function here, right? You have all these bytes, turn this off. You have all these bytes of data here. And then we have the function prologue here. Then we have the epilogue right here. So it takes up this many bytes, right? Maybe what I can do is to try and, do what Minhook does, right? Is I can just copy this entire function's worth of bytes and then uh, move it somewhere else, right? Because they're every time they call it, they're just calling the call instruction doesn't do anything except just set the instruction pointer to that to that instruction, right? And push the return address onto the stack. So when you call return, it'll pop the return address off the stack, or pop whatever's on the top of the stack, and then jump to it is what the return does, right? So that's why the epilogue. So we have the reason we sub. Like, okay, explain this actually better. Sorry, I'm fucking suck at explaining shit 'cause I'm retarded. But when you call a function, it'll push the return address onto the top of the stack, right? So then when you actually get into the function, the first thing the function will do is run the function prologue, which will sub from the stack pointer, allocating space in the stack for local variables and whatnot, right? And then at the epilogue, as you can see here, we add that exact same amount. So then we can pop what is the top of the stack off and jump to it with the return instruction. Does that make sense? Hope that makes sense. So, um, anyways, what I was thinking about doing is I'm going to take all these bytes here and just copy them into a buffer. Allocate the space somewhere random, and then write them there, right? So that'll be the original function pointer. Then here I would just inline my function into here, right? Um, and then as kind of like I guess I'll call it an overwrite hook, where you overwrite the function and add your hook. And then, but we have a check to see if there's not enough memory here, then we can extend it by adding a jump at to where we run out of memory, and then jump to the last part of the function. Right. That's what I think. That's what I think I'm gonna do here. And I think that would be cool because then it'd be kind of like a min hook to where we could be like, all right, so let's go back to our hooker here. So for now, trampoline doesn't really allow you to do that. All right, trampoline hook. If we run, I'm moving a terminal here because it's not, for some reason it crashes in Emacs. I'm not sure as to why, but we can CD here, go into examples. Uh, let me just go to target, uh, debug, examples, and then just run trampoline hook.exe. So trampoline hook.exe, right? Its only downside right now, because it'll do everything for you. All right, so we go to trampoline hook. It'll do everything for you super simply. All right, so we have our hook function here. Um, and then we install the hook, and then we just call print name function, which is Koi. So print name underscore hook will get called, and it will print out the version, but then it returns 6.7. But 6.7 won't be able to be returned, right? That's the only issue with this one. So you can't modify the return value. Which ooh, um, and you also can't change the variables that are passed into it. Like say if you wanted to modify the variable, be like, all right, we're gonna change uh like in Minhook, you can just say, okay, we want to call the original function here and say we just want to pass in a puzzle, right? Instead of the original name, we could do that in Minhook pretty easily. In this, you can't really do that because everything's kind of hard coded. Which I guess it was my first implementation. I worked on it today. I did all this stuff today when I was chilling out. But so everything's really hard coded, right? And I want to make it so that you can pass in different parameters, change parameters, get the actual return value. Because I would like to be like, all right, like say if you call a function, we call this function, would pass in a parameter like fan, right? And then we get its return value. Value equals this. Then we're like, okay, if value is equal to 69, yeah, I mean 69 here. Then you're like, oh, uh, we got 69. You know what I mean? Or you want to do some sort of switch or conditional based off the return value, right? So that sort of thing happens when you're hooking functions. So yeah, so I think I'm gonna implement another function here. Um, we also have inline hook, which is just overriding the first 12 bytes with a jump. Um, but yeah, so I think we're gonna add another function here called overwrite hook. Uh, overwrite. If I can type underscore take an immutable reference to self. Just copy these parameters. Take a target and a detour. And the reason I'm using non-null here is because I just don't have to do null checks on the pointers, so I require the caller to send non-null. For my hooker library, I will probably just accept a raw pointer and then turn it into non-null within the actual you know functions, right? And here we will turn the target's new address. So we'll return back a address. And so turn back a result of a non-null UA the reason we have it is UA is because it is a just makes it easier to do things with it because we're going to be turning it into, maybe a slice of bytes and we want to use it. We don't have to constantly cast things, so we use it as non-null UA. Um, pointers are all the same size anyways, so if it's like a raw pointer to a UA, it'll be the same. It'll be 8 bytes. C underscore void will be just 8 bytes. It's not matter. So here, what exactly do we want to do again? So we want to check the instructions. So they're to calculate overwrite size, we'll just calculate 8 bytes. We kind of want to make a function similar to this. So we'll just call it calculate underscore function size. So this will calculate the size of a function. Let's a lot of things in this file here. Might want to move stuff out. I think probably move all this stuff out right here. Let's call this a separate file called memory.rs. Just move all that nonsense into there. So also allow us to move that into there. So I'll get rid of it, include there. Um, mod. So or mod and memory. We don't need to make that public. Max instruction length is good there. I still don't know what to store in Koi Hook yet, but I know I want to store something in there for disabling and whatnot. Okay. Uh, so we're gonna need that in here. Not found in this scope. Okay, so we're just gonna use create memory and we use everything in there. So let's errors real quick. Takes two generic arguments. It needs to be use anyhow. Result. Okay. Uh, I think a lot of these things here we can actually move out. We really only want the hook functions here to be in here. Uh, disassembler.rs. What is assembler.rs here? Copy bytes will go into memory. Okay. Replace string fun with pub fun. So they're all public. And then that means we can also factor out a lot of this stuff actually. So we should be getting rid of that. Uh Probably gonna need that. Definitely gonna need that also. I don't think we use C void, C underscore void anywhere, yeah. in case, do we need that? Is there any functions in here that use Windows API? No, there's not. I think that's chill. Uh, use create as a mod disassembler. Well, I'd actually like to just not use it like that because that we will need actually this for the offset. Here, yes, we're gonna need that for the offsetium. Okay, so disassembler. But you don't need this. Okay. Guess we don't need to do that. I'm stupid. We also need to take that into disassembler. Copy bytes will be memory. Okay, so everywhere we see copy bytes, replace that string copy with memory underscore or memory copy. Memory protections override. Okay, now we're good to go. So, anyways, yeah, did a little bit of factorization, so things need to get out of hand for us real quick. Little mix action here. Um, yeah, so what exactly are we doing again? So we're gonna take any function. First thing I want to do is check the size of it. So we're gonna make a new function here. Right, so disassembler, calculate function size. Okay. Uh, Alright, so we're going to read in, yeah, we're going to read in and just say a large amount of bytes here. So we'll just say 4096 from raw parts from the function pointer. Just in case we come across some big functions, const max function underscore size, or what was it, size? So yeah, here that'll give us a data. We're reading it as 64. Into iterator, then we're gonna count the size, and I guess we'll just print line. We can have to do that. This thing doesn't need to be an option anymore either. It'd be a straight U size. Then here we need to figure out how we check. So we need to go look at the decoder. Try to use my Emacs keys, great. Alright, so here. So we need to call into iter. You can just call iter, apparently. I didn't realize that. So iter will return back instructions. So it has all these jumps and stuff, but I don't have a return. Op one kind, gets number one operand kind. I think we do want op, well, we want op zero kind. So we want op zero kind, but looking for a return. Oh, operand, we want the opcode. So we just get the mnemonic here. Right. IRET, no. Is there just a normal return, bro? Okay, ret. There we go. Alright, so we can just check. So we can just check to see if the mnemonic. We can just say .opcode if mnemonic is equal to return, then stop. Alright, so current size plus equals this if op.code is equal, or what is it called? So if instruction dot op underscore code is dot mnemonic, right? Okay, dot mnemonic is equal to mnemonic ret, then we will break out. So I think it's really just that simple right there to calculate the size of the function. But if we come across a function with multiple returns, that's kind of a problem. Care about you, so fuck the world. Fuck the world. So all these functions seem to have a CC at their end. Maybe that's just guaranteed. In between, at the end of a function, is there guaranteed there would be a 0xCC byte? I really hope you guys can help me. I've run out of ideas by now. Uh, let's change that a little bit. I don't your code and remember since you have Reddit, right? Trying to enter code and never go again, but not on the functionality. I'm using Visual Studio 22 of the following code. As defaults points out, the compilers and settings actually bytes of your code in order to align the next function on a reasonable, usually divided by 16 second address. Compilers are trying to help you since 0xCC is a breakpoint instruction. All right, so actually, we won't worry about coming because if we do based off of that, then we're fucked, right? So, I think we should be able to just go till invalid is underscore invalid. Now the real question is, do we even need to do that, or can we just loop over it so we get a 0xCC from the start address? Like, that's my real question. Because I don't think we even need to worry about any of that, honestly. It's kind of just a waste of time to do any of this decoding shit. Because we could just take this and then just for byte and data current underscore size. Honestly, we could actually just do for I and 0 dot 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 data dot len. And then if data at index of I is equal to 0xCC, then we can just return I. Now we probably want to return I minus 1 because we don't actually want that. Or actually, no, that actually will give us the right size because it is starting at 0 here. So if we start here at 0, it will reach, yeah, it'll give us the right, yeah, okay. So we can test that out actually here. Uh, for indexing to a raw pointer. Oh, it's a raw pointer, I forgot. So this actually just needs to be uh like that, and then like that. Okay. Expected use size because of return type. Found nothing. What? Returns. I guess we'll return an option of a U size here in case it's invalid. Okay, so live. Okay, I'm not the right one. Memory. Uh, is it memory? Is it dissembler? Dissembler. Calculate function size of target. Um, for now, uh, let's just not worry about that. So if let some size is equal to this, we're gonna then print out the size function size equal to size. And once it gets out in hex, so it's we'll print it out. Yeah. Else print line failed to get function size. So we can eprint ln. I haven't really done that in a while. So this is to be unsafe here. Okay. What's this thing giving us? Detour for its intentional prefix it. Okay, whatever. So making an example here, we'll just call this overwrite underscore focus. We'll just copy everything this one has. Get rid of that. Overwrite underscore hook. Function size 107. Let's check that out. So it should be this minus the start address. Okay, put that in the wrong one. Minus that. That's not even close at all. Okay, we're back. Oh wait, this is the memory function. The hell am I looking at here? This is some bullshit. Okay, I set the wrong function. Let me grab this. So maybe it was right. Okay, okay, it wasn't right. Yay. So we calculated the function size. That was pretty easy. Didn't even need a decode or anything. Thing was pretty slight. So the text section is read execute privileges, so we could just copy over those bytes also. Let's go to the McCoy hook here. So I don't really want to have to do a if let sum here, but we probably will. So I guess we'll leave what was here, and that will be an anyhow error, which we will actually implement that real quick. Error anyhow failed to get function size for target. Okay, and we can actually return that. So we grab the function size. Now we have the function size. We then want to copy the bytes, right? So let function underscore bytes, we call it target bytes, will be equal to uh what was our function called here in memory? So we just called copy bytes. Okay. So so memory copy underscore bytes takes a pointer and a size, and we get the bytes just like that. Oop. All right, so we have the target bytes. Now we also need to calculate the function size for our other one though. So this is why I don't know if I should use an if let sum because we're having a lot of if let sums here. I'll tell you that. So let's just let target underscore size equal this. Let detour underscore size equal to honestly probably just expect here failed to get functions size for target. Alright, so we got the size and the bytes of other functions here. So we just want to check. Uh, let's get size difference here. So because we're going to be placing our detour into our target. The thing is, they're integers or their use sizes. So that puts a little bit of picks here. So I guess we have to turn them into if target underscore size as I asked before. Let difference equal target size for minus will be detour size S4 minus target underscore size as 64. Because we don't have an overflow or underflow here, so so that will return the difference in size. So we're gonna print that out and take a look at it. The difference. Okay, this is still some bullshit. So we're just gonna return it back an OK of a non-null new of a mute standard pointer. Well, if it's a null pointer, then the same thing back in the plan. So we'll just say target as let's see, we'll just return back target for now. The difference is 3. So it means detour size is 3 bytes bigger. So I guess when we calculate function size, we'll probably return back the extra bytes, the extra size. Target extra. Here, we'll just take an underscore because we don't really care about the extra bytes here. Let's put target extra size here. So in our dissembler, let function underscore size. Yeah, she hot and I'm cold. Then we want to calculate to the end of the C's, right? Just want to calculate the end of the 0xC's. We'd have to continue. All right. So if function underscore size not equal to 0, function extra size plus equals 1. And then we're going to say if data at this address at I is not equal to 0xCC, we will break. So now we can actually get rid of the option. I don't need that anymore. And then here we can just turn back and function extra size. So we can print out target extra size.
Would you stop being such a pain in the ass and just
What?
tell us?
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, because right here. Oh, because function underscore size not equal to is equal to 0. It's not 6 though. 1, 2, 3, 4, 5. So it's getting one extra because of this right here. So we're just gonna have to subtract the ones here. To get the actual. So yeah, now we have the actual rise, right? The difference equals 3. Which as it should, we got 5 here, should be 2 right here, yeah. Alright. So here, if difference is less than target extra size is less than or equal to target extra size. If difference, then we can copy all bytes from detour into function, into target. So we can overwrite bytes from target with a detour. So if difference is less than or equal to target exercise, then that means we're going to go to write our bytes, right? So that means that we can go ahead and just write all of our bytes here. So that means we're going to have to use memory copy underscore bytes to readable memory. For the copy to target the detour underscore bytes. The length will be detour underscore size. Is that what it takes? Copy to readable memory. It takes a size and a U8 pointer to source. So I guess dot as pointer. So let's just print line. Difference is less than extra bytes. Copying uh, overriding target. We got an access violation. Interesting. Let me run that from my terminal because I'm pretty sure that should not be happening. That should, honestly, that should work. So let's go ahead and run overwrite.exe. Now it's getting an access violation. copy bytes of memory should just handle that, right? It'll override it. Hmm. That's weird that that's happening. Honestly, don't really get that. So yeah, I don't understand why that is failing to overwrite the bias status. An access violation. Like, what the fuck are you talking about? Memory? I don't understand that. This all looks right to me. We set it to page execute read and write. We cover, then we copy the bytes. Here, what if we try? Can you not? Uh, let's just do. Let's do the target underscore size. So let's write just the target underscore size map bytes. So it won't be good, but let's see if that's an access violation. So no access violation. If you access the padding, does that break it? Because then if we do if we do detour underscore size, even though it's less than, it'll immediately crash it. No, it doesn't actually. It does not crash it. So it's setting access violation right here. Look at that in the debugger and check out what the fuck's going on with this. So just a breakpoint on overwrite underscore hook. So let's full screen this and look at the locals here. Let's stop debugging real quick. Let's build a right hook. Um, let's also fucking let's print line. I need to print out this bullshit. Let's just print out the target. We'll get some reclass to see if it actually overwrote anything. So it's the exact same function. There's only 2 bytes of 0xCC there, so no, it shouldn't be. Do you see a 6-7 anywhere here? 6-7 43. 0x43 should be 6-7, right? Yeah, okay. So let's move that to EAX and that's returning. Uh, drop in place. Oh, we don't care about that. We care about this though. So we got an exception here. I don't really understand why it's getting an exception. So we overwrote all the bytes at runtime. If we can step into it, it shouldn't really matter though. Because it takes the exact same arguments. It does basically the exact same thing. I mean, it shouldn't matter. That's what I don't understand here. Why is this crashing? Can we not use this? Okay, it's gonna use it anyways. Yeah, I don't understand why that would be the problem. Like, what if it overwrites this? Why does it matter? It's because of the Rust runtime? Is that why? Overriding a function's bytes with another function crashes. Why? Okay, I don't. God damn it, you cocksucker. I don't want to do that. I want to just overwrite the bytes. Approaches on five behavior. C center on main versus read. Okay, bro, are you fucking kidding me with this shit? Uh, like, bro, dude, I already know all this shit. I overwrote that. Cache currency. Even if you successfully change the bytes in RAM, the CPU might not see the change immediately. The problem is using instruction cache to speed up execution if the CPU already cached the old function bytes with tuning. Let's see. I'm just gonna have to ask Claude, I guess. I can't find the answer, so let's see if this guy has any ideas. When overriding a function's bytes with another function's bytes that I know fit into the area, and I wrote with readable, executable, and writable, then change back to just readable, executable. Why would it crash when going into the function? So we need to flush the instruction cache. That's probably what it is because it looked like it was trying to access invalid instructions in the debugger. But I had no idea this thing. Flush the instruction cache. It says by process. Handle the process. So we're gonna do that, and that I believe that will fix it. Copy bytes. So we will flush the instruction cache. Uh, handle equal get current process. Handle. Let's look at this. So it's a handle, an object of base address, which will be target as pointer as underscore. Uh, and then a use size of bytes, which will be detour underscore size. Flush instruction dashboard function. I believe this will actually fix it. Let's see, where's it stored as? It's stored under this debug. Parent process is not stored in here. Where's it stored at? Reading. The right. I think that won't work. What the fuck? How the hell does that not work? How the hell does that not work? Oh, that's what's wrong. Oh my God. Because they're trying to use. Oh my fucking God. That's what's wrong, bro. Because in here. So we'd have to go through each RIP relative instruction and update the offset. Okay, we can do that. So the problem is we have to do that exact same thing for print name and print name hook. Those are the probs. We could probably do that though. So we can look at here relative or relative. So yeah, we could say is IP underscore rel is memory operating. So we can check to see if they're RIP relative MO, and if they are, then we can go and change it up real quick. So we can check that out. We can probably fix that pretty quick. Um, you can probably just say fuck that for now and check to see if it works out the print line. So let's see if the load val here, let me run. So yeah, if we return back 6.7, right? Because we don't have the RIP relative here. So our function works. We just need to go through and fix RIP relatives with fix up. I guess we can call it a little fix up action. Let's see, does this actually matter here for the flush cache? Let's see. No, it doesn't. We will leave it though. So do find out if flushing cache actually matters. For now, we're not gonna worry about that. So this works, right? Because the override does. We're going to need to do a fix Uppington though. So yeah, we will check that out. So bytes. So these are the bytes. We will just fix up the bytes. So fix up uh target underscore bytes. So it's assembler fix up target bytes. I'll also fix up a detour underscore bytes. So target bytes will be fixed up with, and we're not actually going to fix that up yet. We will fix up this detour bytes with the new address, which is going to be target. Uh, we'll pass it the new address. I guess we'll just call dot address on this to grab the address from it. Fix up relatives. Fix up func relatives. Oh, this is similar. So we can write it down here. So the func is at relatives. It will take a U8 bytes and then a usize address. I guess we will original underscore address. So we need to get a disassembler, so let's just copy and paste this shit from other function here. A decoder. For ends and a decoder dot iter if ends dot is RIP relativimo. Let's print line. Can we get print line? This thing apparently it can be formatted, so we can maybe print this out like this. Oh, okay. We need to not actually do any of that. Bytes. Why is that mutable though? Okay, I don't know why that's the case. Oh, so we actually need to go back. Um, right, look. They're good with loaded peptides right there. So that is going to be. I'm not sure. Here, let's go print underscore. Guess that would be this right here. Okay. So in the disassembled.rs, we have this RIP relative instruction, which it's just these bytes right here. So we can calculate that here. It's going to be 1721B. So it should be this plus this plus the size of the instruction, which is going to be 1, 2, 3, 4, 5, 6, 7. So 1722 uh, from this instruction will get us here. So yeah, uh, so to update that, if we are going to write that, we would take. So we're gonna be moving this by this. We would take the difference in the addresses, right? So if we took this, subtracted it by this, and then added our previous number, which I didn't fucking save. Okay, so let's save that real quick. This is 70, and then we took in the main function here. Okay, so what is it? Fucking 1721B plus 7. Right from here, if we were then to add an extra, let's say 70, right from there, and then we are to go to here and go minus. If we can do minus, we can. It'll then put us here, which is the other load address. So That's basically really all we have to do here is fix up relocations to let relocation underscore difference will be equal to address as I-64 minus original underscore address as I-64. And that will give us a negative number, which we'll add to the RIP relative instruction. So for here, um, decoder new, can we actually have a mutable decoder that references that memory and writes to it? Or is that not a thing? Probably not a thing. Opcode info, no. Memory. So I'd like to do that. The thing is, this is not a mutable reference to the actual memory itself. I wonder if we can do that though. Uh, so let's go back to decoder here. Can we do that? With an IP, try new, no. Can we do it with a mute? So now we can't actually modify the memory. But decoder options. No, so we can't do that. Okay. We can, however, memory displacement 32. Well, no, we just need to modify these bytes actually. What am I talking about? We don't actually need to modify the memory itself because it's before we write. So we're fixing up the displacements. Can we then take a decoder and just turn it into bytes? Is that a thing? Decoder bytes. I wonder if we can just turn these instructions into actual bytes. Bytes. Looks like they have a instruction to turn it into bytes, I guess. Not really sure why though. Six bit IP instructing a set IP. Okay. So I guess we'll just set an IP here. So decoder new with an IP. So decoder with underscore IP, and we will set the IP equal to uh, original address, right? And then we'll take a mutable reference to a slice, I think here, and then we can modify that slice. So detour bytes. So we'll take a mutable reference to a byte of slice here. So if it is a memory operand, then we will grab its uh, so first we'll let IP equal to ends.ip. So we'll grab its instruction pointer. Then we will, let's see, then we will let uh, relative offset equal instruction dot relative. So mirrors 32. The thing is that that should always be 32 bits if it's accessing from. Yeah. Pivot offset. Okay. Then we will take uh, bytes at index of IP minus original address plus the size of Image dot length minus mem size underscore of I think I32 here for the offset. So we could also just hard code this as 4 for now. So we would start at this. Right. Set this as a pointer. So as a mute underscore pointer. Cast it into an I32. And then we're going to dereference it and set it equal to, let's see, we're going to set it equal to relative offset. So relocation address, relocation difference will be address, and then we'll add the relative relocation difference. I think that's what we want to do. I believe so. I believe so. And this will be wrap in unsafe. So I think that's what we want to do. And then we will just I would like to then overwrite this. We'll read back the memory and then print it out to the screen to see what it's changed to. So let's look at this here. So create instruction. Uploads are cleared by decoder. So can we decode? Decodes, return those decode out. So create a decoder here, and then decoder dot so we set the position equals set underscore position to IP minus original underscore address, and then decoder dot decode. And we'll print line the new instruction. So original uh new. So it's a lot of stuff there. But kind of not really much of a choice here with this. Actually, is the decoder takes a reference to data. I guess we're just better, kind of better off just making this a U64. Because or else we're just gonna be doing all this shit. I'm gonna have to do that anyways. I mean, this kind of shit is fucking annoying as fuck. U64. I guess honestly, we kind of better off just doing that. And we kind of don't even do any of that. Cannot borrow as mutable. Cannot borrow an at reference as mutable. Okay. We Does this work the way I think it's gonna work though? Is the question. Or should I just take the bytes as a new pointer and offset it? I think we're just gonna take bytes dot as a pointer. Add IP as relative underscore. Or let's just grab that entire code right there. Hmm. So I was kind of scared of Teebs to the H or Reno. Yeah, it's gonna be Problemo. Think we will just return a uh new slicer Reno here. I think that's what we might end up doing here. Or we could just dot clone this right here because it doesn't really matter. So you can't clone an entire U8. I calculated this right. Right. The IP is gonna be the original address plus that minus the original address plus length of this interruption minus 4 for the offset. Yeah. Yeah. I mean, yeah. Yeah. Fuck me. Um. Fuck me. Fuck me. What do I want to do here for this? I think we're just going to. I think with the, I want it to be like this, but I don't really feel like I'm gonna pass a vec. But I guess I could just pass a vec of U8s, pass, and then just clone it here, pass a slice into there, and then we can just say bytes as the pointer here and overwrite some stuff inside of it. Okay, we have to actually make a binding for it, so let bytes underscore clone equal bytes dot clone. So yeah, it failed overriding. Misaligned pointer dereference address must be a multiple of 0x4, but is 0x2e9. So it's a misaligned pointer. Uh, so it would be 3 from there. So 6, 9. Yeah. So we would like to write an unaligned mnemonic. Uh, no. Rust docs. Right underscore unaligned. So I think this is what we're gonna do instead of having to do all this nonsense. We will just add that, not worry about dereference anything, and just call it right unaligned, and just write that into it. This is the original right here. That's a bit of a difference. That is a bit of a differential. That's not right at all. Is going to be the problem. Yeah, that was not even close to right. I'm not sure what the fuck just happened there. 6, 5, A. Yeah, that's not even close. Uh, the relative offset is this thing wrong? Print line relative underscore offset. Yeah, that's not even remotely close to what it is. What in the absolute fuck? That is a bit strange. Ain't that the truth? What in the fuck is happening there? Why is the effective address just complete nonsense? And it's an RIP effective address, right? Relative memory operand. That's relative. Yeah. Oh, it could be an IP relative memory address. Relative. So it's trying to get a displacement. I don't think that's right. Maybe it's this. That's why it's not working. So now it's just giving the absolute address. Yeah, that's not good. It's supposed to give an offset. Screen driver displacement 64. I don't know what the fuck is going on here. I thought this would just give me the fucking offset, but it's like going full fucking retard. I just have to grab it myself. I'm not sure. Yeah, it's just giving me the entire address. Like, what the fuck is going on here? Maybe we're supposed to be U32. This thing's giving me a U32 displacement. Is it fucking stupid as hell? Why is it not giving an I32? Because that's what it is. What if we minus the IP? Will that change anything here? So E492. Is that even fucking close to what the thing is? Not even fucking close. Yeah, I literally have no idea what the fuck's up with this thing. I guess we're not even gonna try and grab it from here. We're just going to grab it from here. So let pointer equal this. Let value equal pointer dot read unaligned. Let's print line value. Let's just not even worry about decoding this shit again because that looks like fucking shit anyways. Uh, let's just print out the value here. E32AP. So let's go have ourselves a clip and see if that's really what the fuck this thing is saying. Uh, let's. So maybe the memory offset was right. I just was looking at it in the wrong thing. I don't know. Because we're gonna find out. Even if it's not, I'm just read it from here anyways. So I'm not really gonna sweat it. Come on, baby, load for me, load for me. Let's go. Okay. So it is that value. E32 AP. So let value equal ends dot. memory displacement, memory underscore displacement 32. So the thing is, that's not even close to what it is. Yeah, so I guess this thing just brain damage. Just not worry about that. Bound ends. Right? So it should be really just as simple as pointer dot right underscore unaligned the value, right, which is an I32 plus our relocation difference. BB28V. Yeah. Why is it changing that? What the bug? Circle bit, the gas of the week. Like, so it's print line the difference here. I want to see what this is. So we're gonna just take a look at this and see this difference here. Because it should be really in the same order. Minus. So it's 112. The thing is, we need to add the opposite of that to this, don't we? So we actually have to do original address minus this address.
Step into my smoke box where I cash out, having visions of my death.
Because we're going to write.
Lately my nightmares look like the cover of Hot Boys Let 'Em Burn. It's the most violent,
That to
unregistered
over here, right?
What's the reason I was sent to Earth? Put your motherfucking head on curb. I come
And then yeah, so that's gonna be chills for us. So let's see now why this isn't working. So that should be good. The difference here. Um, the IP line. IP. So 70 looks about right. But what is the offset of this? So yeah, so everything looks good to me. I don't. Yeah, I mean, all looks good to me. Relocation looks good. Everything looks good. Okay, let's just I guess debug it and see what happens. So this is the instruction here. RDX is going to be RIP plus that. So what the fuck is happening here is the question. So what the fuck? This is a relative call, isn't it? So this is a relative function call. That's what's happening right here. And our little thing did not tell us that, did it? So we go to our assembler here. Is an RP relative memory operand. Of course, I fucking put that shit there. Fuck me.
With many broken souls steady what
So we have to fix that memory operand. Rel relative. So all they have is this call flow control info. So we probably want to check if it's a indirect call. Um, and then if it is an indirect call, call regs. So let's see if it's an indirect. So really just want to check if it's any of these right here. No, not actually an indirect. Fuck. Not indirect. Indirect is when it jumps to a register. So we need to be able to check whether or not, because it's breaking right here on this call. Now, the reason I don't want it could just be like that shit. Because what if we have, like, let me open up a different project. Let's just open up, oh no, let's not open up that 64. Uh, just open up Cracker.exe, for example. And we got a call right here from EDX. Oh, this is going to be some this is also a 4 byte relative. Huh. Interesting. I'd like to see if it's just a call or a jump, then we can grab it. See, yes, let's just call flow control. Um, if ends dot flow control, if it is a flow control, well, okay, now we say let flow equal this. Let's then match on flow. Um, I wish I had a cursor set up right now. So let's replace dash string equals with equal that. Um, so match flow, conditional branch return. So they should all really only have one operand, right? I'm saying like they all really have only one operand. Uh, I really wish there was just this ability to say like is arc relative, but and just grab all of them. It's just not gonna understand what that is. Yeah, it's fucking annoying as hell. So it means we're gonna have to kind of don't really care though if it's one of these. We kind of just want to check all of these though. Does I wonder if these branches. So let's use opcon. Um, opkind, opkind. So op zero underscore kind. Op zero underscore kind. So we're gonna match the op on the op kind here, and we're just gonna check these. So I'm just gonna say um we're just gonna sit on this and just print out the instruction here, I think. Found RP relative branch. What the fuck is going on, bro? What the hell? I'm having linker errors because I'm running the debugger. I guess it was. So I found all these different branches. Let's see. So we have a right hook has call 1, 2, and 3, which are all relative branches by the look of it. Should put a calculator and find out. 37, 37, E3. Oh, so those are all working because we're in it. We just need to update their offsets here. So Um, so specifically, which one are these though? It should be a near branch 32, I'm gonna assume. So call, let's take a look at that. So call believe those are called near, as we can see here, with the relative displacement. Uh, those should be near 32. Found RP relative near branch 32. Guess there are 4 branches, I guess. Or if it's a near branch 34, that kind of wouldn't make much sense though, but uh, so they are near branch 64s. They are near branch 64s, okay. We would like to get the instruction link. Let's see.
I never fucked with it, but I lost my mind. Homicide the sedative. 1 is 9, you get pulled apart by the hands of the damn dismemberer. Put me in the damn electric chair, I got a fetish for it. Yeah, I said it. I got a fetish for the electric chair, so put me in it. Hit the fucking switch and let me get it. When they do electrocution, then they make you put a diaper on and shave your head. I got demons in my sleep that won't let me get back to bed until I'm fucking dead. Executioner, executioner. When I was on Earth, it was stupider. Let my soul fly into the universe. God knows what I'm about to do to her. Behind the velvet curtain, death is certain, so it's all I think
The fuck am I
about
listening
before I
to?
peace out on.
Okay, that song was complete horseshit. So we'll just say ends. Let's see if this actually gets the relative thing here. 'Cause, I mean, this is a relative displacement. Relative displacement. So ends up memory displacement. Let displacement equal this. I think the displacements should be I-32s though, so I don't understand. Displacement. Does anything use either to set immediate? I'm also gonna try immediate 64. See, it's getting the displacement from what in the fuck, dog? Is this thing absolutely retarded? So it's saying it's a register. Are you, like, do you have Down syndrome? Like, bro, what?
New software update available.
I don't know. I don't know where the fuck it's supposed to grab the value from. I'm just gonna have to grab it on my own, I guess. But the thing is, it can be multiple bytes though. But if it's a 32 relative, then we can just do our little trick here. Uh, so we can just do our little trick here. IP instruction length -4. Right, and it's the exact same thing there. Alright, so now the function works. So that's kind of annoying though that I have to do this manually. Like, is this fucking library branded? Or do I have Down syndrome and I don't know how to use it? Like, maybe I'm retarded as fuck because like maybe I'm a dumbass. I don't know, but all I know is that that should be we need to factor this part out here. Uh let's make a function here. Function right. This will just take a reload relock and if 64 by 32 and a value by 32. Well, for now, we'll make this. Well, maybe be type T because if we need to do a 16-bit. Right, so relock bit also need to be the same type. Type T, it should. Let's actually just add cargo num underscore trades. And this should implement num underscore trades. Crim and So that's gonna be chill for us. We're going to set this as an I-32. Alright, that works pretty good. So, we have to handle a lot more stuff here, though. I need some water real quick. Alright, so a quick 2 hours and 44 minutes. Not really too bad. I mean, it took me longer to put this because using library. I didn't really understand that well, so I had to read about it. But this is pretty chill. I mean, all we really need to do here is just go through and update these as we come across the functionality, I guess, in the actual cheat. So I could probably just well, actually, now we need to do the same thing, but with so we need to now remap. So to simpler, now that we've done this, right, we then need to do handle target being larger than or detour being larger than target plus extra underscore bytes. So we're gonna do this to do here. We're going to actually handle writing our target. So we're just gonna assume that this is all done, which it is for this case. Then we're going to actually write our target. So we're just gonna call virtual allocate here. So let's go see. I think we did it earlier over here. So it's going to virtual alloc that. So virtual alloc new underscore target underscore address. This will be target underscore size.
A fuck about none of you little boys. You foolish young niggas need to know I got a choice. I could beat your ass or just cut you cause I'm bored. My blade so sharp I almost cut myself. These niggas need to know I don't need help. And all these rappers know not to dare step to the wolf man for a reason. Hollow Squad hunting all season with the scout regiment intervening. And bitch, we don't die for a reason. We put death on you industry heathens. You see Thunderman sitting on my left now. And we came from the terror in another round. I cannot give a fuck about nothing now. You see truth in my floors, I don't need a ground.
The source we're going to copy memory from will be our target underscore bytes that we saved. array, target underscore bytes does underscore pointer. Yeah, and size will be target underscore size. So that will copy all the bytes from our target bytes to our new target address. And then we will, before we do that, we will fix up relativiums. So fix up relatives for target underscore bytes. So original address will be this. New address will be new underscore target address dot address dot into. I guess we can just call this new underscore target. Okay, then we'll copy the bytes over there. Then we will overwrite the memory. So let's copy this function over here. Okay. We will override memory protections for target or new underscore target. So overriding protections will take a pointer to a C void dot as is it mute? Yeah, it'll set that underscore target size. Okay. That should be Gucci. We have to use the memory here. Target underscore bytes. That mutable reference here. So now if we come to our examples, overwrite, and we can actually then call let return let value equal print underscore name. Um, hi we hi from inside print first name we hooked it up you heard. Okay. Then we're actually just gonna return value. So value should be 0, but it should print off this stuff now. And which it is. So wait a minute though. So it printed off this, but never printed out that. Now, this is probably because we're moving print name to a new location, but what the fuck is going on? How the hell did this just call that though? That's what I want to know. So hooked input by was coy, but then if we call print name from within the function, it won't print out anything. So difference is less. Oh, because we're not handling the fact that print underscore name underscore hook is larger than print name. Alright, so we actually didn't hear that error checking there, so we didn't realize what happened. Void hook here. So else, panic, not handled, bigger, detour, yeah. So it will handle, not handle bigger detour. Yes. So with this, the problem is going to be, so let's print line the difference here. Difference. So it adds a total of 30 fucking bytes for one call. Are you fucking my dick? Let's get rid of the value here. Let's see if we just call this how many extra bytes load. 20 extra bytes. Sheesh emo. Okay, well, we're gonna have to. So the way we'd have to handle this is by jumping to a new memory location. It's by allocate more memory or yeah, allocate more memory, and then jumping to it and setting that to read write privileges, right? So, uh, so if this is the case, we will write. So we're gonna need enough memory to do an absolute jump here. All right, so we're gonna create a jump to our new location. That means we're gonna need to create a jump here. So memory, do we have create jump in here? No, it's create underscore JMP. So we're gonna create a JMP. So first we're gonna virtually allocate some mem here. Let target underscore branch equal this. Let's go and what does create jump take here? Oh, time it in here. So this is simpler. Create jump. So it's gonna take yeah, it's gonna take some stuff here. So we're gonna need to that prefix to it. Target underscore branch dot as pointer. Let jump underscore bytes equal this. So it's actually gonna make things a lot more complicated actually now. Because now we're going to jump to a random ass location in which we're going to need to refix up the relative offsets from that location. Right? We also need to make sure that we don't cut an instruction in half. Okay, so like, we're gonna jump over. We don't want to accidentally copy just these bytes right here and cut instruction in half. So we're gonna need to loop through the instructions. Which I think I already made a function for that. I believe in my disassembler here. Calculate override size. We can use that. I think the name's not really as fitting now. So calculate. Let's look at like instruction size, I guess. Calculate. Uh, calculate size rel to ins. So calculate size relative to instructions. So let's go and compile our code here. Cargo build line 20, huh? Calculate underscore size rel to instruction. So we're gonna wanna let's see. So we're gonna wanna have 12 bytes left over in space, right? But then enough space for so we're gonna have to leave 27 bytes left over. Right, because the maximum instruction count is 15 for an extra instruction. So create jump will be this, right? Then when we write our bytes to here, copy bytes to real memory. Copy bytes to real memory. I have to copy to the target address. Detour express as pointer, not detour size, but detour size minus the difference. Uh, minus jump underscore bytes dot length minus disassembler uh max instruction length. Okay, so that's what we're gonna have to do there. So that'd be like what, something minus the difference minus this length. Let's go and store that here. So but new underscore size will be equal to this. New underscore size. Alright, so that's the amount of bytes we'll write over to there. Then we need to calculate our new bytes. So let new underscore bytes equal this. This will be equal to our detour underscore bytes. And actually, we can't do what we just did here. We need to first calculate. We need to first calculate the size relative to the instruction, right? So calculate size relative to the instruction, in which we will pass in the function pointer. Okay. So calculate size relative to instruction. Target as for target new underscore size. Yeah, so let size equal this. So this will get the okay, this will loop through it each instruction until the current size is greater than the length that we passed in or equal to it, right? So let's see what ends up being used to this right here. Uh, and then let's pass in new size here, and let's print out the sizes here. So underscore size, target underscore size, actual underscore size. This is similar. Fixed use size 5964. Okay, that is. Uh, um, do that. This new size is 95, actual size ended up being 97. Right, and what is target size? So, what is target size again? So, or oh, we overwrote target size here, right? This is actually going to be uh detour underscore branch. I'm going to do this. Detour underscore size, target underscore size, target underscore branch. Fuck me. New detour. Oh, no, new target. So detour branch here. Calculate the size relative to instruction. We don't want to do target. We want to do detour. That's probably what was giving us some weird stuff going on there. So yeah, we actually need to do make sure that we always have enough room. We have to do disassembler. Okay, there we go. So we now get a new good size here. So uh all right, dope, dope, dope. So that works there. Now we want to just we can just unwrap this. Detour underscore size. But we won't have the original detour size. We do that though, right? Detour bytes. Yeah. Uh, detour underscore new size will be that, and then we will take leftover equal detour underscore new size. Right, and then yeah, I'm not sure what the fuck this shit is. Doesn't really matter. It's gonna be aligned anyways. But this we're gonna say 12. I'm gonna need to do all that. So leftover would be that 12. I don't like having mysterious numbers like this. So let's just club const jump underscore len. See, that'll work, I think. And then here we will just. So we're allocating new space with leftover bytes. Then we're gonna have to. Then we're gonna have to actually look at those bytes themselves, right? So we're going to have to perform fix-ups. So perform function fix-upiums. So fix up relatives. So fix up func relatives. The original address, which was detour. So fix up. Oh no, this is gonna be detour underscore branch dot address. And the original detour dot address here as the original. It's equal. We have a vec from slice. We'll just call vec vec underscore and detour underscore branch slice dot extend underscore from slice. It will take in a slice from detour underscore bytes. Detour underscore bytes from, let's see, uh, from detour underscore new underscore size and on. Yeah, then we'll call detour underscore branch underscore bytes here. And we will see if that works. Hook input value was koi. 0. Okay. So it looks like our fix up function actually works very well here, it seems. For now. Because that was actually pretty easy to implement. Thought it was gonna be a little bit harder. Well, actually, it's because we're not actually um, oh, this is the trampoline hook. My bad. Okay, we are doing this. Thing is, it's returning 0. So that crash, we try to store the value. Interesting. Uh, relatives, yeah, I mean, that's all chills right there. So it breaks when we do that. It's also because the print names in a new location, which we're not actually fixing it up. That's why. So the print name is just silently failing, I guess. So we can check our .rs koi hook here. See, a printf, maybe it's just causing it's 3 hours and 19 minutes. I mean, we can probably fix this real quick. I don't think it should take that long. So this function here is being allocated to a new location in which we would need to fix that up, which that means we'll have to do it before we do all that, right? So so we have to write our target to a new location before we do that. Then we will apply our fix up to our new bytes. And within here, we will have to, so fix up function underscore relatives. So because we put a check to see if there's a call to a relative function, right? Because take a look at our code right now for this example. There's going to be a call, right? So we can take a look at that in the debug or the reload. Let's load this up real quick. Because it's going to be a call to our function here, so we could just do a check to see if the function matches our target address. And if it does, then we will modify it to the new target address. Or whatever the new relative jump is going to be, right? So yes, it's gonna have a call to here. It's gonna be the print name, which will be the target address. So we can add a check for that in our fix ups. So assembler here, fix up. Let's just add a check here. Or function is target address. Oh no, we're gonna need to do that. We'll first set up here. So if we find a branch, so update relative offset. So we can just read here, turn back to type 2. So read underscore relative offset. So we can first read underscore relative offset and just take the exact same parameters here. The reason I'm not just saying I'll return a value of other relative offset is because I just don't really feel like setting two different functions. So let offset equal this. Print line. So if offset plus I pizzle that means it would be calling the old address that we're overriding, right? Print line. Relative call to old address.
Young Jax Teller, bodies in a cellar. Jose Kellen Keller, they ain't speaking, they ain't telling. Butterfly play, never rock a fade. Got a few satanic ways for these fuck boys on my way. Skin it white, 7 days a week. Smoking on that PCP, sipping on some DMT. Never X to rap, cause I don't like you motherfuckers. Always on my back, bunch of biting motherfuckers. 5-9 my fucking brothers. Got your bitch under the covers. Is that Mary Jane burning? Syrup got me slurring, turning down on them spokes. Hang me from a fucking rope.
Why did this not print anything out? Pretend this IP is actually 4 and see what this happens. Bro, can I show this as a fucking integer? You shit ass calculator? Okay, that's how you do it. So it's the negative 226 one right here. Um, Posted on the sticks and the glick and the podcast. So that's why it wasn't working. So search. Find a relative call to an old address. Then we want. Excuse me. We're gonna fix up that address, right? Um, we're just gonna give an option here. To use size be new underscore address. Alright, so if let some new underscore target underscore new underscore then we'll have to update relative offset here. But by updating relative offset, we would need to go in and um, do the original location difference will be different though. Location difference how we calculate it right now. The original. So this would actually be this would be original minus underscore target underscore address as export as each size. Yeah. So it's not the original offset, then so function relatives. So works with the other one though. Will this work for here? I honestly don't know. Because this is going to be in a whole new location here. Let's do the here too. So if it's these relative addresses, it will take that new location, it will calculate a new difference, which would be the original address minus the new address. Calculate the new offset, right? So oh shit, this is not where this goes. So just new target, new underscore target. So it's still fucked up. Shit, fuck me. So I'm gonna look at this in a debugger and see what this looks like to see if it's actually patching the right address. Because honestly, I have no fucking clue. Uh, so let's go back to source here. Um, so let's go into here. So here's where we actually grab a new address, right? So whoever locals here, our instruction pointer is, let's see right here. So we can look at that in V class to see is this actually instruction pointer. It's a call here, so we should get the new target address, which will be new target address. Fuck me. But the right hook. What the fuck? That's not good. Um, yeah, that's no bueno right there. So It is the function. It's just not starting at the right address. If the one passed in there is not the right address, why is that? Interesting. So we write straight to new target, but new target has no bytes at the beginning of it. That is a bit odd. I'm not sure as to why that is. Um, let's restart. So we're gonna write, we're gonna fix up those relative functions. We copied that's memory, but it copied 1, 2, 3, 4, 5, 6, 7 random ass junk instructions. How the hell is that possible? That's something I don't understand here because we're going to use this address later. Thing is like, fuck my fucking asshole. God damn it. So the function's fine. It's just somehow copying 7 random horseshit bytes. I have no idea how it's fucking even remotely possible. Yeah, I don't know what the fuck's going on there. So let's look at this again. Target. Where the hell is new target at? Okay. So new target is here. And I fucking did it again. God damn it. Fuck me. Alright, so we copy memory to new target. Which we can see target underscore bytes has 7 null bytes or 7 random bytes that don't exist. Can we elaborate on this? I'm not sure how that fucking happened. Uh, so yeah, Target has, let's see. So Target has the right bytes, right? So how the fuck does it end up not having the right bytes? So we step over this. So now target underscore bytes. So target underscore bytes somehow copies some random ass shit. So pointers colon, we allocate some bytes here. Take this pointer. Yeah, I mean, let's just really cool bytes from here real quick. So we check it out. Yeah, I mean, we're Gucci with it. We have our bytes here, which are nulled out. We copy. Like, where did these 7 junk bytes just come from? That's what I want to know. Look at function right here, where it copied bytes from. And somehow it is copying some random ass shit. I'm not too sure what the fuck just happened. Yeah, that is really something I cannot explain. I'm not finna cap. Copy underscore 2. Alright, bro, I'm heading to bed, dog. I have no idea how it's possible, but I guess it happens. Not sure what the hell happened, but